Okay, we're getting down to the nitty-gritty. Next, we have Jim Murray, who is Regional Vice President of Infrastructure Sales for Pictometry. He's had 30 years plus in industry, and he's worked for not only Pictometry, but Quantum Spatial, Kodak, and Bausch & Lomb. He's a member of JITA, and he has received degrees from SUNY and got his Master's of Business Administration in Syracuse.
Thank you, Tom.
Where's your review? You have 20 minutes.
Okay, so we're on the countdown, and my promise to you is that I'm going to try to give you a few minutes of your life back. So that's my goal here. And so we're going to work through this rather quickly. But the agenda for us this afternoon is fairly straightforward. I want to talk about up front a thing called the metric oblique, and the reason why that's important is it kind of lends some context to the rest of the presentation, which is what is some of the best practices in the industry in terms of ACA determination and verification. So we'll start out with talking a little bit about what this metric oblique thing is, and then we'll quickly kind of go through some of the components of integrity management and HCA determination. Talk about what a lot of the industry has been doing, kind of the common solution. Then kind of move into some of the benefits of ortho and oblique imagery. How does that help? What can we do with it? What's the value? What are some of the things that we should be considering? And then a little bit about why imagery in and of itself has an important role in terms of providing a primary data source, something that you can lean on during times of maybe audit or reflection. Something that you can really point your finger on and say, this is why I made the decision that I made. A specific use case, maybe, if we have a little bit of time. And then just kind of a quick primer on if you're going to go through this process, if you're thinking about you want to add imagery to your workflow, here's some of the considerations. So, kind of imagery acquisition 101. All right. So what is this metric oblique thing? Well, it's an image that's shot from an oblique angle. That it's in our case, it's shot from about a 40 to 45 degree angle, and that gives you a great deal of perspective. And in addition to it being an oblique perspective, it is all georeferenced. So that means every pixel in this imagery has metadata, and therefore can be exposed and utilized and consumed in your GIS. So how does that work? Well, how do you get an oblique image? Well, this is just a very simple graphic that shows clearly over here on the left we have the way most aerial imagery is captured in a traditional straight down approach. So you have a very nice square image that geospatial software absolutely loves. Then on my right, you have the oblique image. And if you notice, it's not square. Well, that causes all sorts of nonsense for geospatial software. They just hates it. And fortunately, we have a way of helping geospatial software understand it. But as you can see, it's trapezoidal. So as you look at the image, as you move from the bottom to the front or to the back, you go from a higher GSD to a lower GSD. And there's some permutations, some algorithmic nonsense that we have to go through in order to make use of it and better understand it. So as we fly along, we're shooting traditional ortho imagery, and then we can also shoot this oblique metric image. And I'll explain a little bit more why that's important. So another graphic, this is how, at least in our case, of how we would approach a corridor collection. As you notice, there was 3 different kinds of image polygons. There was a traditional square one, that's your ortho. So as we're flying along, we're shooting the traditional ortho, and at the same time, we're shooting a forward and rear-facing oblique. So we're being to get in one single pass a tremendous amount of data because we have a lot of overlap. So every second or so, or even less than that, we're actually firing these sensors, and we're collecting a tremendous amount of data. And as you can see, that gives you a complete overlapping picture along the corridor. So. And this kind of gives you the sense of, okay, well, what does that allow me to do? Well, here's your traditional ortho, and I'm sure some of you can probably figure out what that ortho image is. But when you turn it on its side, now you really see what the total perspective is. And you can just begin to understand how much more data is exposed to you when you turn that image on the side. So now we can see the vertical surface, we can see it in context, we can clearly see what that structure is all about. And in our world, not only do you get this kind of ortho perspective, but you get it from all four cardinal directions, which gives you basically a complete picture of that universe that you're interested in. So enough of that. But I needed to kind of share with you what the oblique, metric oblique might mean, because we'll talk a little bit more about that in context as we go further through this presentation. So one of the things that I wanted to cover was, why is my timer going? Who's got the timer?
I do.
Okay. I wanted to keep it myself so I knew where I was. Never mind. So, a couple of things about HCA management or integrity management HCA analysis. This is where much of our technology has come into play in recent years. And so a number of things that we've learned, and this is probably not new news for a number of you in the room, but we have, there's a number of regulatory compliance issues that come into play when we talk about integrity management, especially as we're talking about gas pipelines. One of them is, providing digitized structures. I'm not going to go through all these in detail because I promised to give you a few minutes of your life back. But identification of places of congregation, like churches and schools, how the land used, identification of outdoor public areas, and then, where applicable, defining buildings that are 4 stories or more, because any of us that are in the gas pipeline world, that's usually the red flag for an immediate HCA. So these are kind of the typical things that most operators are trying to chase, and certainly there's more of a detailed list, and each operator has a different, slightly different take on what's important to them. But these are the kind of typical major top-line things that most people chase. And in addition, if we look at the identified sites list, these are, again, the kind of the typical areas. You got the outside areas, you got facilities where mobility might be limited, and then you've got occupied businesses, and I won't read the list, you can do that yourself. So, common solution. So this is kind of what I see on a routine basis in industry. And this is how many operators have been, or in some cases are still, approaching their HCA, their class determination and their HCA verification. So in most cases, we start out with readily available imagery that's free, and either the ArcMap catalog or NAPE imagery, something in Google, whatever they can basically lay their hands on at no cost. And there's a lot of intelligence for doing that. I'm going to make a case for something other than that. But they're usually starting with that. It's usually a meter, maybe worse, oftentimes not that good. And as you can see from the image above, it's a fairly, it might be good enough, but it certainly doesn't give you a great deal of clarification. Generally, our clients then, or these clients, usually tag their structures by either points, or in some cases, very rough building outlines. And it really depends from client to client what their appetite is and how they approach it. And what they really rely on is extensive field verification. And that's really at the heart of what their process is, their workflow is field verification backstopped by some of this freely available stuff with points or polygons. So here's some of the common issues that we see with this. Low resolution imagery really prevents you from making any determination about occupancy. So you need field verification to do this, right? That's how you're going to do it. If you can't tell from a picture, you're going to send people on the ground. You have a very difficult time doing any kind of high precision structure outlines, which also then complicates your ability to do automated change analysis, which in many cases is a tremendous work saver in the workflow. If you're able to make determinations, what's new, what's demolished, What's changed, it certainly shrinks down your field of requirements dramatically as a GIS workload. And then the third point is that it's usually the field personnel that are, they're the ones that are the authors of the information. And whether we want to admit it or not, no matter how well we try to train our field personnel, from crew to crew, there's going to be a different interpretation, a different implementation of that training. And so you're not going to necessarily get a consistent return input from those field crew reports, right? And so as a result of that, there's a tremendous amount of internal standardization, normalization, use whatever term you want in terms of what you need to do to clean up the data. So, greater resolution, obviously I'm no camp with greater resolution. Yeah, I know, I'm the poster boy for that. And as you can see over here on the right, low resolution, when you're doing polygons, it's going to require you to be a little less precise. Over on the left, you can see a much higher resolution imagery, and obviously you can be tremendously more precise in terms of that polygon. And what does that mean? Well, it means that we can be more choiceful in terms of what structures fall within and what structures fall without our right of way. So the oblique perspective, and this is where we weave that back in, is that allows us now from the desktop with high resolution imagery to make some determinations about what those buildings might be without necessarily having to send a field crew out there, without necessarily having to interpret what they see. We now see it right from the benefit of our desktop. And here on this image, this is a very classic example. If you were looking at this from a top down, it'd be a structure that you would have to send someone to verify because you wouldn't be able to tell what it was, but you knew it was big enough that it was something that you'd have to make a determination on. And here you can clearly see that it's not a building for human occupancy, it's some sort of a material shed or equipment shed. Also with the use of high resolution metric oblique imagery, you can determine the heights of structures. So with one very quick 2 clicks, you've got the height of the structure, you know that it's over 4 stories, and there's your automatic HCA. Beautiful thing. So, benefits, they both have a place. One of the things that obliques will continually provide you is a tremendous higher degree of context about what's underneath that right-of-way. Here's a very elegant example of being able to make a determination of what this structure is from that oblique perspective, because you can see the cross. I would defy anyone on the planet to be able to determine that from a traditional ortho imagery. That cross would just simply disappear. Same with finding small equipment pieces that give you indication of what's on the ground. Here we have a crossbar for a football field. You know immediately that's where going to be a place of congregation. So you're going to have to do something about that, right? So, data source, primary. This is where utilizing high-resolution imagery that has been pegged to a collection timetable provides you a referenceable data set in which to be able to justify the determinations that you've made along the right-of-way. I've got a time, I've got a place, and I've got the data that says here's what's on the ground when I took that, and now I have something that I can use as a backstop to justify any decision that has been made. We'll just keep going. I already talked about that. So let's use a case of Cheniere Energy. And I was struck by Josh's example earlier, where you're talking about new construction and how you're utilizing this great technology to be able to pretty much benchmark everything that's going into the ground. Well, Cheniere is only about, I don't know, a 7-year-old company. They were built primarily as an importer of natural gas, because if you recall, a few years ago, the sky was falling, we were going to run on natural gas, and we then created people that could import. Cheniere was one of them. And as part of their operations, they built this huge pipeline, 100 miles. I know, I'm being facetious. But what they did it with best of breed. So everything they put in the ground, they knew exactly where the welds were, they knew what type of material, they were very proud of that component. But what they didn't really spend as much time on was understanding what was the the structures around that pipeline. So while they knew all the stuff underground, they didn't necessarily have a clear way of verifying what was along the right-of-way. And that's where this metric oblique came into play. And as a result, one of the kind of the side stories is that in their class structure file over here on this image, they had those two structures identified as not for human occupancy. When they utilized a high-resolution oblique, as you can see over here on the left, you can see that that's certainly not the case, that they were multi-family dwellings. And I think one of the tip-offs is here, the trampoline at the bottom of the screen. If it was a cow barn, most cows don't use trampolines. So, again, the whole point is high-resolution dated imagery provides a tremendous amount of capability that not only improves the quality of our data, but also, more importantly, exponentially speeds up the determination and therefore getting our results in. So, what am I making the case for? I'm obviously making the case for, use imagery. Use imagery, use high-resolution imagery, and one of the things that we've learned over a number of years is that most of our clients find that if they're using a 6-inch GSD image, they're getting all the necessary information they need out of it in order to be able to make the determination. And 6 inches provides a kind of a middle ground between the granularity and the swath in which to cover your right-of-way. And that, obviously in aerial imagery, it's a function of height over ground. The higher you fly, the wider your footprint, but the coarser your GSD is normally. The lower you fly, the narrower your swath with, the higher your GSD. So the kind of combination here is 6-inch gets you the kind of swath width that normally most people need. And if you're going to acquire it, a couple of things that you want to make sure that you're interested in. One is that you get a spatially accurate product, that your horizontal accuracy is somewhere around plus or minus 3 feet. Anything greater than that, and in our opinion, you're wasting your money. The other thing that you want to keep in mind is the timeline for your project. Now, I understand that time is money in business, and as a result, when you finally do make a decision, your next reaction is it here yet? Did you shoot it yet? Can I have it now? What about now? What about now? So what you want is a vendor that can absolutely deliver on the timetable that they've suggested, what you've agreed to. So do they have enough capacity to do your project in the timetable you've required? Do they have a track record of delivering on time? In other words, vet your potential provider on these kinds of scales. The other point of this is how can they delivering the data? How do they get it to you? Do they have a way in which they can deploy it to you in a manner that you can consume it within your workflow? Do they have integrations with all the major geospatial software? Do they need the integrations? Do they have a way of deploying it through the web? Do you want to deploy it through the web? All those kinds of questions are really important to ask. So can they deliver to you in the way you want to consume? So, how much time do I have? Yeah, great, perfect. So, we want to make sure that when you're looking at a vendor that's going to supply you high-resolution imagery, let's make sure we're comparing apples to apples. Make sure that you're comparing the financial numbers fairly. Are they going to charge you for a setup fee? Is there fairing fees involved? Do you have to pay for delivery fees of some order? Is there maintenance fees? Are there any other ongoing costs? All of those things do happen, have happened, so those are things just to be on the watch out. Get a sample of the final product. Make sure you understand what the accuracies are. Is the vendor delivering what it has proposed? So, in conclusion, in my humble opinion, the metric oblique provides a tremendous, important advancement in our ability to do our work right from our desktop, and enables us to do it faster, better, and cheaper. It gives you a referenceable data source in which to be able to justify the decisions in which you make in terms of the data in your class structure file. And frankly, at the end of the day, it really is cost effective. When you compare the rest of the workflow where you're bringing in, utilizing field crews, the time, the cost, you're going to find that utilizing high resolution aerial data as part of this HCA class determination and verification really is a cost effective tool. And look at that. Right on time. Shut up. Okay, questions?
Got time for one quick question.
What is the survey control requirement for your oblique imagery?
Say that again?
Your survey control requirement for your oblique imagery?
In our case,
Second
it's
question.
ours is direct registration.
Yeah, for auto images, you place some control on the ground.
I'm sorry, I'm having a hard time hearing you.
No, what is in terms of number of control points, how many control points you need for your oblique imagery?
0.
So then how do you validate your metric oblique imagery horizontal accuracy?
Well, we won't certify it. Ours is a planning grade, but we have evaluated it consistently to be under plus or minus 3 feet in all conditions. So we do it through direct geo-registration. Okay?
One more quick question, sorry. Is there same level of concern regarding leaf-on, leaf-off conditions for oblique imagery versus traditional also?
Well, you know what? That's a very interesting question. It depends it's a depends question. It depends on what your application is. Obviously, leaf-off in all conditions is going to give you a much greater perspective of the ground. But even with leaf-on conditions, that ortho or that oblique perspective is very likely because if you remember all the overlaps through all that series as the plane progresses, you're likely to see a portion of the ground that would give you the information that you need. Thank you.